We call our planet the Earth, yet two-thirds of it is covered by water. We can't live in the ocean. To us, it's a strange and dangerous place. But for a fantastic variety of plants and animals, the ocean is home. The seabed may be covered with plants, but as they need sunlight to produce food, these seaweeds are found in shallow water. As no light reaches the deeper parts of the ocean, all the plants float in the sunlit surface waters. But these plants are so small that they can only be seen through a microscope. What these strange plants may lack in size, they make up for in number. In 1 cubic meter of seawater, there may be 750,000 microscopic plants like these. Floating among these plants are numerous tiny animals. They too may spend their lives afloat, feeding on the plants. Or they may be the young or larvae of larger creatures such as crabs or snails, which grow, become heavier, and finally sink from the surface. All these plants and animals that drift in the surface currents are called plankton. They form the diet of many larger marine animals. These plant-like shapes are corals. Inside the hard skeletons are tiny animals that at night stretch out tentacles through holes in these rock-like formations to catch plankton drifting by. Barnacles are more energetic feeders. Any plankton sieved from the water is tossed back into their open mouths. Plankton is also the diet of some of the largest animals in the world. The devilfish, or manta ray. The two horns on either side of its head help to sweep plankton and small fish into the wide mouth. The manta ray grows to a fantastic size, more than 6 meters across and weighing as much as 20 people, so it needs a big mouth and a whole lot of plankton. The manta is only one of the thousands of creatures in the sea, all living off each other. As well as the plankton that float and the fish that swim, many other creatures live on the seabed. Anemones, sea urchins, sea cucumbers, scallops. They jump, you know. The whelk. All these creatures spend much of their time feeding, until they themselves are fed upon by others. By studying the ocean, we can learn not only about the creatures that live there, but also about their environment, the water. Dolphins are masters of the water. They are mammals, just like us, but they can swim 5 times faster than we can. We're clumsy swimmers, our shape's all wrong. Because water is thick, we need a shape that can cut through it easily. A streamlined shape, like a dolphin. Dolphins have powerful muscles to propel their beautifully shaped bodies through the water. Many fish are also fast swimmers. The movement of the tail drives them forward. These streamlined predators are able to move quickly through the water to catch their food, such as a shoal of pilchards. When an octopus wants to move faster than his legs will carry him, he becomes a more streamlined shape by swimming backwards. Unless an animal has a streamlined shape, it's not going to get through water very quickly. Fish that are not streamlined are slow movers and may have to wait for food to come to them. Without oxygen, all animals would die. The dolphin, being a mammal, fills its lungs with air through a nostril on the top of its head. It can stay underwater for more than 5 minutes, and certain whales can last for 2 hours before coming to the surface. They blow out the stale air from their enormous lungs and fill up again with 2,000 litres of fresh air. They can't use the oxygen that's dissolved in the water. If we want to stay underwater for more than a couple of minutes, we have to take special air-breathing equipment down with us. Most other marine animals get their oxygen from the water itself. A fish sucks water in through its mouth and then pumps it out through openings behind its head, called gill slits. With a dead fish, we can see more clearly what happens. Under that cover are delicate structures, the gills. The surface of each gill is covered with tiny blood vessels. As the water flows over the gills, some of the oxygen in the water passes into the blood vessels and is carried by the blood round the fish's body. So, animals that live in water and have gills are able to use the oxygen dissolved in the water. Can you imagine walking to school underwater? Of course, you'd need your own oxygen supply, and you'd have to allow lots of time to get there. These men can't walk any faster because not only are they the wrong shape for cutting through the dense liquid, but they're also having difficulty keeping on the bottom at all, even with lead weights around their middles. The water lifts them up, and without weights, they would rise to the surface. But the creatures that live in the sea don't seem to have this problem. They can remain at any depth in the water without the help of weights. How they do this can best be shown with an experiment. In this tank of water is a model fish. A long tube runs from outside the tank to a small balloon inside the fish. The balloon represents a special organ called a swim bladder, though in a real fish it is much smaller. This model fish is too heavy to float, but by using a syringe we can push air through the tube and into the balloon. And if we take some air out of the balloon, by adjusting the amount of air in the balloon, the model can be made to float at any level in the water. It's the same with a real fish. Its own very small swim bladder, like the balloon, contains air. With special glands, it can alter the amount of air in the bladder. The more air, the higher it floats in the water. The less air, the lower it sinks. You can work out for yourselves why man needs lead weights to go deeper. But not all fish have swim bladders. Fish that live on the bottom don't need them. But other creatures without swim bladders, like sharks, have to keep swimming to avoid sinking. These strange noises are made by these fish, appropriately called croakers. Sounds carry further in water than they do in air, so some marine animals can communicate with each other over long distances. The sea is far from silent. The dolphin makes sounds in order to find food. This experiment shows how he does it. The dolphin's eyes are covered, so he can't see anything. The dolphin makes a sound which bounces off any food back to him, telling him where the food is. Here, rings are dropped into the water instead of food. The animal with the loudest voice is the whale. He doesn't use it to find food, but to communicate with other whales up to 1,000 kilometers away. You'd look like this too if you were to dive far into the ocean. This reinforced suit contains enough oxygen for a 20-hour dive. There's even a telephone to talk with others on the surface. This suit is as heavy as 6 people, yet in deep water it becomes almost weightless. It's made of steel because the deeper you dive, the greater the force of water on top of you. This suit will protect the diver from the great pressures of deep water, but only down as far as 500 meters. A dolphin can dive deeper still, down to about 700 meters. This dolphin has been trained to dive into the depths and take his own photograph. The pressure of water at this depth has crushed his lungs. This pressure would kill a man. How the dolphin survives is still largely a mystery. The sea holds many secrets. In fact, half our world is covered in water more than 2 kilometers deep. Yet life still exists in the world of darkness beyond. Strange fish have been caught. Most are only a few inches long. Some have shining lights to attract a mate or a meal, and enormous mouths to catch creatures as large as themselves. They eat well when they can. These are only models. Few people have ever seen living deep-sea creatures. But now you are able to see for the first time remarkable scenes recorded by an automatic camera on the bed of the ocean. First, at a depth of 1,300 meters below the surface. On the sandy floor, 3 kinds of fish fight over a dead victim. These creatures are called hagfish. They're not really fish at all, because they don't have jaws or proper teeth. Yet they have a gluttonous appetite for dead or dying fish. The camera probes even deeper, down to 2 kilometers below the surface. The bait attracts other strange fish out of the darkness. And it's not only fish that live here. Crabs do too. And there's something drifting through the camera lights. 2 kilometers below the surface is a jellyfish. Now, the camera is lowered to a record 4 kilometers under the sea. In total darkness, where the temperature is only a few degrees above freezing, the pressure of the water is like having a half-ton weight on every square centimeter of your body. Yet, life still exists. In the distance, a solitary fish appears, slowly drifting along, using as little energy as possible. As we learn more about the world's oceans and the creatures that live in them, we realize how different life underwater is from our life on dry land. In this environment, it's likely man will always be a stranger.